Welcome to another episode of Gray Hair Garage. How you doing, Mike?
I'm doing very well. How are you, Rich?
Pretty good, pretty good.
Excellent.
I've enjoyed editing all the 82
I bet you have.
episodes.
Yeah.
And that's including this one here. So we're just going to continue on with the 82 engine build.
Yep.
I believe that's what this episode's going to be, and it's a small series. A lot of information, so we've cut it up into a few episodes.
Yeah, just to understand it, a lot of what I'm giving you is general stuff, but some good key points like the silicone and a few other little items.
Yeah, and if you ever have questions about the build, you can always send us a message on the Facebook page.
Yep.
Or right on the video itself, and we do generally answer everything.
We try to. We try to get with everybody that leaves comments, and there's been a lot of questions about the 70, and there's been some questions about this, that, and the other. We try to answer it as honestly and as best we can. So
do our best.
Yep.
So anyways, we hope you enjoy this episode, and we'll see you soon.
Yep. See you soon. Okay, guys, so let's do a little show and tell here. Finally got the engine disassembled, and this engine and I have a little bit of a history. Now, I bought this engine from a buddy of mine. It is a 347 short block based off a stock 5.0 block. And, well, I got the engine to put all together, and I noticed that I didn't have any oil pressure. Something crazy was going on. And just happened to notice when the engine was running that the crankshaft was moving around on the front snout. And if you look here at the balancer, you can see all these little marks. Well, that was touching the timing pointer. Anyway, somebody, when they had built the engine, and this is kind of a little bit of a long story, but I'll try to shorten it up. But somebody had built the engine. Well, when you do stroker cranks in Fords, they base it off a 28-ounce balance counterweight setup. whereas the new model stuff is 50 ounce. Well, whoever put the engine together apparently put a 50 ounce on it. So anyway, when that happened, what it ended up doing was actually messed the crankshaft up. It had, anyway, screwed it up pretty bad. Bottom line, didn't have oil pressure. So I had to disassemble the whole thing again. Went through it again, put a new crank in it. Had one of the local machine shops balance everything out. And so now we're back in it again because of smoking issues. So you can see here on the number 1 main. See if we can get in here really good. Yeah, I don't know what's going on. And there, all the bearings, they're just screwed up looking. I don't know if you can tell with this one. But anyway, something's going on with this engine. I don't know if something's jacked up on it. Maybe it's just me and I'm getting old and stupid. But anyway, we're going to take a look. See what my options are. I may just buy a short block and be done with this project. I don't know if there's something wrong with this block itself. Maybe I don't know. Anybody got any ideas? Leave some comments. The bores look good, but all the wear on the bearings just look goofy. And I've never seen one like this. I mean, usually you'll see some wearing. Like on this one here, it's all polished on one end. And you still see the Babbitt, the original finish. And it's just like that all over. Just it's I don't know if the cranks, I don't know, like a rubber band or something. And it's the same. You look at all the mains. Here's the front one. You guys probably don't care, but anyway, we're going to figure this thing out. We're going to do something.
A few moments later.
Okay guys, I just wanted to touch on a couple of things here. First of all, one of the things I decided to do, rather than send that old engine block over to the machine shop and have a bunch of work done to it and still maybe possibly have some of the same issues, I think this car has been running some kind of supercharged or nitrous application, and I think it's caused something to go wrong with this block. And rather than keep going down the same road I was going, I decided to go this route. Now, found this company. It's Krebs Engineering out of Rhode Island. They built me a 347 stroker motor, all scat stuff, TFS pistons, and so as you see, it's kind of just standard stuff. Put the cam in, the roller lifters and the followers, the retainers and all that stuff. So all that stuff's done. The balancer's on. I've got to get a water pump. So kind of what I wanted to discuss, let's flip this over. One of the things that most of you guys kind of wanted to, is the distance between the pickup tube and the pan. You always, between the pickup tube and the oil pan, you want to have somewhere in the neighborhood 3/8 to 1/2 inch clearance. Always measure that. I just measured it. Put a piece of clay. I actually did some measuring with some straight edges and stuff, but I don't know. There's the clay. So I put the clay on. There's the clay. We'll take the pan, flip it over, line it up best you can. Now understand that there's still gasket going in, but you just make sure it presses down, and then you lift it back up. In this case, it stayed on the oil pan, but you can see that is roughly 3/8 of an inch. Now you throw the oil pan gasket in, so you're going to be in between that measurement. I said 3/8 and 1/2 inch. That might be a little closer to quarter, but by the time you put the gasket on, which is a little thicker, and this particular one is a Felpro unit, and it's got the metal stops on it. You can see the little inserts. So yeah, so that's the engine. This oil pump, this one here, that is a Melling. Let's take a look at the box. So 10687. Looked that up, do a little research on it, but bottom line, it comes with 2 springs. The one that's in it is a brown one, and it's good for, say, 60 psi hot and running. And then they've got a green one in there that's good for about 75 psi or so for you know, hot conditions running. So it's a little higher, but in the case of this car, I think I'm going to err to the high side than the low side, and because that's the same setup I used in the Capri, and I love the oil pressure, never had a problem. It's just a standard volume oil pump. It clears the stock oil pans, and anyway, so yeah, this Krebs Engineering 347 short block is a nice piece. It looks great. Everything's ARP. So let's hope it does the job and makes this little 82 run good. Talk to you later. Talk about cylinder heads for a minute. So what I ended up doing on this particular engine is as I was cleaning the heads up that came off it originally, I started noticing several things, and this is one thing I can say about anybody that's disassembling engines: you need to inspect things really well. And so if you look around in some of these areas, like right through here, there's several other little spots. These heads need to really be skimmed one time, probably 5 thousandths, 10 thousandths will clean them up. So another reason why I went to new cylinder heads, because if you see this surface area right here, there's more of it. So now I'm not going to have a problem with the headers leaking anymore. Well, let's just say I shouldn't have a problem with the headers leaking anymore. So what I ended up doing is upgraded the cylinder heads. I went from 170s that were originally on it, which are good cylinder head, to the 190s 11Rs. And also, while I was at it, I decided to up the size of the combustion chamber from 61, I believe it was, on the 170s to 66, which dropped the overall compression ratio down to about 9.6. Overall, I think these heads are going to be a better choice for this engine. When I did it originally, it was shoestring budget. I was just building an engine based on some basically used parts here, and so now this time around I'm kind of falling into the same line of thinking when I did the Capri engine. So this should be a pretty good little setup. Like I said, you can see it right there in 190s. Nice looking head. Yeah, we shouldn't have any issues now. So we're going to start putting the cylinder heads on. Now on these particular heads, you're going to have to run, Trick Close sells them, but basically these heads are set up for 1/2 inch studs, and so because this is a stock block and it's 7/16, so you have to have these little hardened reducers. put those in the head. They fit inside each one of the stud openings and bolt openings, whatever you want to call it. And anyway, you get it. You understand what I'm saying. So the other thing I went with was they're sold by Trick Flow. They're Cometic, but you can see the Trick Flow. This is for a 4-inch 30 thousandths overbore. So they're Cometics. I had these on the Capri. Of course, the Capri was a 363 with a full 125 bore. But so anyway, we're going to bolt this sucker up, get a little bit closer. We got to do a little bit of touch up here and there, but hopefully you guys are enjoying this. I'm trying to cover some of the stuff. We'll get into the valve train once I get the heads on. Kind of show you a little bit about how to set those up. Anyway, hope you're enjoying. Okay, like I said, most of you are probably watching. You saw me use Moly Lube, and also I used the Permatex thread sealant. And the reason being is every bolt, you look over here on the head, every one of these bolt holes go into the water jacket. So what I'm doing is, I've had this problem in the past. I'm doing something I've never done before, or I haven't done in the past. I'm putting thread sealant on it. Doesn't affect the torque rating and all that. I just want to make sure that when this engine goes together that there's no leaks anywhere. One other thing I did on the head gasket is I used, and again it's something else, it's a Permatex spray gasket on the head gasket. It's just a little extra reinsurance. Like I said, you don't have to. I put that 363 together in that Capri and didn't have any issues with it. But I just thought, what the heck? I'm here. I'm putting it together. I want this engine to be perfect, or as perfect as it could be. So anyway, let's carry on, move it around, and we'll get on to the other side. I just wanted to cover a couple things. When you're putting the intake on, what you want to do is right here on this water jacket, because that's the only one that's open to the intake manifold on a 289, 302, 351 Windsor. You got to trim this little corner over. Just basically opens this area up so to match the intake better. The water flow will go through without any restrictions. And one thing I like to do is use a little dab of Weatherstrip Adhesive. This is the particular brand that I just had floating around, but I like to put some on the gasket and some on the head. That holds it in place. And then also, one thing I want to cover while we're here is use RTV in these areas on the front and back. Don't pull out and use the corks. You will not be happy. Now these particular heads are TFS 19011Rs. So this particular intake gasket is 1262. And one other little thing that I like to do also, and this works for any time you use silicone, put you a little dab somewhere. This stuff takes about 15 to 20 minutes to glaze over, and just use this as your test piece. You just put your finger in it, and when you can pull it away and you have very minimal, if not any, silicone on your fingers, thing's ready to assemble. That's one of those little deals nobody really covers, is you don't want to put the RTV on wet and just assemble it. It does a better job when you just let it set up for a little bit. And like I said, depending on the temperature and all, but 15-20 minutes, and then you'll assemble it. And of course, you know, cleanliness, you got to keep everything clean. And one other little thing I like to use is I always keep a can of wax and grease remover around, and the reason being is it's cheap. It's a lot cheaper than you know, like brake cleaner, but anything works. Brake cleaner, wax and grease remover, lacquer thinner, alcohol, but wax and grease remover seems to work best for me, and that's why I keep a can around. Anyway, hope these little hints, little help tips, whatever you want to call it, hope they work for you in the future. And let's keep on assembling.